everyone. Today we will be solving the question house number 2 with bottom up approach. So, do you remember how we did the bottom up approach of house robber 1? We used to first make a vector array and then we would make uh, uh, save first two indexes of that vector, and we used to iterate it through from I is equals to 2 to n, and we would used to take two variables that it skip, which means that skip the current house and go to the next index, which basically means t of I minus 1, and we used to make another variable called take, which used to take the money from the current house and jump to the I plus 2 house, I minus 2 house. So in this approach we are going to do the same thing, but interestingly how we did the recursion and memoization method, where we used to make two cases, where one case would be to go from I to n and the second case would be to go from 2 to the first case was to go from I to n minus 1, because we can't take n as 1 and n are neighbor to each other. In the second case we used to take from 2 to n, because we can't take 1 because 1 and n are neighbor of each other. So let's solve it. I'll make first int n is equals to nums dot size. Okay, that's done. And I'll make a base case that if size of our array is 1, then we just return the only element it has. So vector will make a vector and dp of size, okay, I'll name it t for now, of size n plus 1, and initially I will take all the elements as 0. So what I'm gonna do is take the first element of the array 0, and I'll just start my case 1, that is from 1 to n minus 1. So for int I is equals to 1, I less than n minus 1, I plus plus, I'll make the necessary two variables and skip, that means go to the previous go to the previous house and take, that is take the current money and go to the house that is 2 step backwards. So which basically means nums of I plus t I minus 2. Now here's the catch, that we need to make a condition for here, because here if I is equals to 1, then here it will be minus 1 and it will go out of bound. So what we can write here is that plus if I minus 2 is greater than or equal to 0, then we can put it as t of I minus 2, else 0. This is it, and at the end I'm just gonna save the value, that is int result 1 is equals to t of n minus 1. So I will first clear the vector, because we are going to be entering the case 2, so we need a fresh vector. So case 2, what the case 1 was to go from I to n minus 1, the case 2 would be to go from I is equals to 2 to n. So let's make the base elements, that is t of 0 is equals to 0 and t of 1 is equals to nums of 0. Now we have to keep it 0 as well, because we want to skip the first house. Yeah, now I'll start my for loop. So it's going to for and I is equals to 2, I less than equals to n, I plus plus, make and I'll just similarly make this, just copy paste here, and I'll save result 2. Okay, I missed one thing here, that that here I was supposed to take the maximum of skip and take. So basically because we need to initialize the ti, so it's max of, it's going to be max of skip comma tick. I will just copy it here and paste it, and I'll save result 2 as t of n, and I'm just simply gonna return max of result 1, result 2. Let's just run it to see if this works or not. Okay, so we are getting a lot of errors here at line 11. Okay, I have not initialized it. I think it's supposed to be 0. Line 40. It's suppose max of result. Result. Okay, I have not declared result 1. Okay, spelling is wrong. Okay, and the last one is 30. Result is equals to 2 of n. Okay, let's try to run it. So we are getting a runtime error. Okay, so what if I just write it as t I minus 2. Let's see if this works. Let me find the solution. Okay, so I fixed the mistakes that were happening here. So the major mistake was I was looping from 1 to n minus 1, but I was supposed to go from 0 to n minus 1 and 1 to n, and I did make some conditional statement for skip and take here also for skip and take. And now let's try to run it. Okay, I'm not now able to run it. Now let's try to submit it. I hope it passes because earlier it was getting memory limit. Okay, so using the bottom up approach, we find the most optimal solution. There are more constant time solutions for this house robber question, and we will be seeing that in the next video. Thank you.